Hello everyone, my name is Atish and topic of this learning video comes under the topic application of integral calculus. In this learning dialogue, I will be talking about volume. Okay, so suppose you have a curve. So this is your x-axis, y-axis, and you have a curve y is equal to f of x. So if this is a curve y is equal to f of x, then what we have to do, we have to find out a volume. So if I take an arc of this curve, okay, and let me mark this point as x is equal to a, this point as x is equal to b, then the volume of solid generated by revolving the area bounded by the curve y is equal to f of x, f sisa x is equal to a, x is equal to b, about x-axis is given by volume v is equal to integration a to b pi y square dx. Okay, now come back to the figure. Now we have a curve y is equal to f of x, and what we are doing it, we are taking an arc of this curve, okay, and this is x equal to a, x equal to b. Now what exactly we are doing here is we will revolve the area under this curve. So this is the area I am talking about. Now a solid will be generated if this is the area bounded by the curve. Now when you revolve this about the x-axis, so the solid will be generated, and the volume of that solid is given by this formula. Volume is equal to a to b pi y square dx. Now this is not the case always. Sometimes you'll be given a curve in terms of x is equal to y. So if this is your curve, say x is equal to f of y, okay, then the area bounded by this curve, say this ordinate to be c and this ordinate to be d, then the area bounded by this curve x is equal to f of y, when this is revolve about the y-axis, then it will generate a solid, and the volume of that solid in this case is given by volume v is equal to integration c to d pi x square dy. We can write systematically the volume of solid generated by revolving the area bounded by the curve x is equal to f of y, ordinate y equal to c, y equal to d, about y-axis is this. Okay, so on the basis of these two formulas, we'll take an example to work out with. So this is the example that we are going to work out with. This example is a patent example of many examinations. Okay, so let us see what is this example is. So the example says find the volume of the solid obtained by revolving the ellipse about the x-axis. So first of all we are going to draw the ellipse. So we are drawing an ellipse. So this is an ellipse, and what is its equation? Let me mention x-axis, negative x-axis, y-axis and negative y-axis. Now this is an ellipse whose equation is given to us, x square by a plus y square by b square equal to 1. Okay, now this is the ellipse, and as you all are very aware that the ellipse, this is the standard ellipse with semi-major axis 2a, so its length will be minus a 0 and this point should be a 0, and semi-minor axis will have a coordinate 0 minus b and 0 b, this point. Okay, one remark I would like to make before we find out the volume. What is important in this is the limit. These plays a vital role in finding out the volume of the solid generated by revolving a curve. Okay, so this is all done, and as we have to find out the volume about the x-axis, so my limits would be minus a to a, or what I can do 0 to a and multiply it by 2 because the curve is symmetric about x-axis and y-axis. Okay, so let us start with the given equation of ellipse is this, and as you know the formula just we have discussed, so try to get y square from here. So what is it? Y square is equal to b square into 1 minus x square by a square. We have to find out y square. So y square by b square is 1 minus x square by a square, and then b square multiplied by here. So we have this. Now let us find out volume. Therefore volume of the solid generated is equal to integration. As I said, this curve is symmetric about x and y axis, so you can write either limit from minus a to a, or you can write 2 times integration 0 to a. So I am gonna write integration 2 times integration 0 to a. So this is 0 to a pi y square dx. Okay, so multiplied by 2. Now this is 2 times integration 0 to a, pi I can take outside. What is y square? Just we have seen y square is b square into 1 minus x square by a square dx. Now what you can do is you can take out all the constant outside of the integration and apply the integration. So integration of 1 with respect to x is x, and integration of this 1 by a square constant, integration of x square is x cube by 3, and limits from 0 to a. Now this is same as 2 pi b square, apply upper limit minus lower limit. What will be getting? In place of x put a, so this is a minus 1 by a square into a cube by 3. This is just the upper limit, minus lower limit will contribute to 0. Okay, so this is now 2 pi b square. What about this? A square get cancelled with this, so a is remaining, so I am taking a outside. Remaining is 1 minus 1 by 3. So 1 minus 1 by 3 is 2 by 3. So this is 2 pi b square a into 2 by 3. So what is the volume we are getting in this case? Volume is equal to 4 pi a b square by 3 cubic units. Okay, so this is the volume, and let us write down the final answer. It's a good practice to write down the final answer. The volume of the solid volume of the solid generated by revolving the given ellipse, revolving the given ellipse is equal to 4 by 3 pi AB square cubic units. Okay, now try this problem I would like to give you. I want you to solve the same problem. Find the volume of the solid obtained by revolving the ellipse about y-axis. So you can try the same example. The only change is we have find out the volume about the x-axis. Now you have to try at home that you have to find out the volume about y-axis. So if you go with the volume about y-axis, so what is important? Important is this limit 0 to b you can take and multiply it by 2. So what would be the change, or what would be the answer that you will be getting? So you can comment your answer in my channel. Okay, and if you have any doubt, please ask. Thank you for watching this learning video.